Okay, we're going to have a look at forces and how they affect acceleration. Now, if you remember in the last presentation, I said that the acceleration, the calculation for it is acceleration equals the change in speed divided by the time taken for the change. Okay, so it's the change in speed you need to make sure you remember. I also discussed the fact that you could look at the gradient, and the gradient, which is the acceleration, is the change in speed divided by the time taken for the change. Same thing. So now let's have a look at forces and how these are used with acceleration. Forces make objects change their motion. The change can be a change in speed or direction or both. For instance, when a football is volleyed, the force from the player's foot changes the ball's speed and direction. We can describe these changes as an acceleration. When a car accelerates away from traffic lights, the acceleration is caused by a thrust force from the engine. And forces make objects accelerate. If the force acting on an object is in the same direction as the object is moving, the object's speed will increase. If the force acts in the opposite direction, the object will slow down. Okay, and we see this in action when a book slides across a desk. If the forces acting on an object are balanced, its speed will remain the same. Now, if you apply the same force to different objects, they may accelerate at different rates, and this is because of their mass. The greater the mass of the object, the lower its acceleration. And I think this is common sense really, because if you apply the same force to a motorbike as you did to a lorry, you'd know that the motorbike has a much less lower mass, and so will accelerate faster than a lorry. Okay, so if two cars have the same mass, then the one with the higher driving force accelerates more quickly. Okay, so the one that puts his foot down the quickest is the one that's going to go the fastest. So if you were asked to calculate force, again you can see this is the equation you'd be given at the front of your paper. Force equals mass times acceleration, and as I said, and I keep saying, put it into a triangle. Anything above the divide line, well, in this occasion there is nothing above the divide line, so your mass times acceleration will go at the bottom, leaving the force to go at the top. Okay, but don't forget the units as well. Force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. You must remember the squared part.